Hello there, Year 9's Mr. Herman here, and this is exercise 5F, solving quadratic equations using factorization. The learning goals for this lesson is to understand that for the product of two or more numbers to equal 0, then one or both of those numbers must be 0, and to understand that a quadratic equation can have either 0, 1, or 2 solutions. The success criteria is to be able to recognize a quadratic equation, to know how to rearrange a quadratic equation so it can equal 0, and to be able to apply these steps required for solving a quadratic equation using what's called the Null Factor Law. So the whole premise of exercise 5F is to utilize the skills that we've learned in 5A and in 5E to be able to solve quadratic equations. So to backtrack a little bit, what we're so used to is, say for instance, we have an equation that looks like this: 2x plus 3 is equal to 0, or 5x over 2 minus 8 is equal to 19. I'm not going to solve it for now, but we're so used to solving equations like this by applying inverse operations. You work backwards until you get an x solution by itself. X is equal to something. When you substitute that x value back into the original equation, these will equate. And when you apply these inverse operations, you're doing it one step at a time, or one inverse operation at a time. The highest power within both of these equations is 1. Okay, x to the power of 1. And so using inverse operations is quite simple to do when this is the case. However, now that we're dealing with quadratic equations, it's not as simple as just applying inverse operations. And the whole reason why we look into factorizations in conjunction of using the Null Factor Law, which we'll see in a second, is the whole premise of trying to solve quadratic equations. And the reason why we solve quadratic equations is so it helps us with sketching quadratic equations. Or in other words, if we have ax squared plus bx plus c, and you know what your a, b, and c values are, and you wanted to sketch this quadratic formula, putting it into a format where you can factorize it and then solve for the y and x intercepts, that's the whole reason why we look into the skills that we've learned within exercise 5A to 5E, and then ultimately 5F. So we can get something that looks like that. We can find these 3 important points. Math Methods looks into also finding the turning point of a quadratic formula, but namely these are intersections. So right now we're just going to look into or hone into the maths component onto it, not the sketching part. That will be later down the track. So the result of multiplying a number by 0 is 0. So any number that you multiply by 0, no matter what type of number it is, fraction, decimal, negative, if you multiply it by 0, you will always result with the number 0. So consequently, if an expression is equal to 0, then at least one of its factors must be 0. And this is what we call the Null Factor Law. And this provides us with an important method that we can utilize to solve a range of mathematical problems, namely quadratic equations. So let's delve into this. The Null Factor Law states that if a product of two numbers is 0, then either both or the two numbers is 0. Okay, let's put some maths or context to this. Let's say, for instance, that we have A and B. They're two random numbers, and when you multiply them together, they give you 0. What the previous facts were stating is that in order for this to work, either A has to equal 0, or B has to equal 0. Maybe both of them equal 0, we don't know. But at least one of them has to equal 0 in order for this equation to work. You can't multiply two non-zero numbers together that will give you an answer of 0. It's impossible to do. Okay, you can try two different negatives, two different negative decimals, it doesn't matter. You will always get some type of numerical answer that is non-zero. So the only way for this equation to work, at least one of them has to equal 0. So now we're going to apply this logical fact and implement it into an example here where we have x times x minus 3 and this is equal to 0. So a in this case is the x, and the b is the x minus 3. And we've got these two x's here, yes, but this is saying that either in order for this to work, that has to equal 0, or this has to equal 0. So now we're in a scenario where there's potential for this to have more than one solution. So in other words, x has to equal 0. So then when we plug in the number 0 into this equation, this will work. Or the other scenario is if x minus 3 is equal to 0. So if x minus 3 is equal to 0, what should our x value be? Well, if we plus 3 onto both sides, our x value is equal to 3. So right now, we have two plausible solutions, which is what they've written here, in order to plug back into the original equation for this to work. So there's more than one potential solution. There are two different solutions. When x is equal to 0, so when you substitute 0 into this, this will be 0 multiplied by negative 3, because at least one of them is a 0, this will equate to a 0, so that works. And the other number that works is x is equal to 3. If we substitute 3 into this, this will be 3 times 3 minus 3, which is 0, 3 times 0, which gives me 0. So this works as well. These are the only two solutions that can work for this particular equation here. If you substitute in another random number, say for instance 1, this will be 1 multiplied by negative 2, which gives me negative 2. 1 doesn't work. Okay? In fact, all other numbers you can try do not work. The only two numbers that do work is x is equal to 0 and x is equal to 3. So this is what this null factor law is stating, that at least one of these has to equal 0. Let's come up with the scenarios where it does, and we can try to figure out what our x values are. To solve a quadratic equation, okay, so this right here is a quadratic equation. In order to solve what x values can be when they are equal to 0, we're first going to write it in standard form. So we have to have pretty much everything all on the left-hand side, and this has to equal 0. And then you're going to factorize using your factorization skills that you learned in the previous exercises to get into a format of bracket, bracket, multiplied by bracket, bracket, equaling to 0. Sometimes in this scenario you might not have two brackets, you can only have one. That's okay. You will get a scenario where that works, or that happens, sorry. And then you just use your null factor law to say either this is equal to 0 and this is equal to 0, and then you solve for your x's, or whatever relevant letters they use. Pro numerals. I stand corrected, pro numerals. If the coefficients of all of the terms have a common factor, then you first divide by that common factor first. So this is another important rule that you've got to consider, because you will run into scenarios where this is the case. Alright, let's delve into our first example. We're going to do two sets of examples, and then I'm going to split this video up into two different parts, because else it will just be too much of a long video. So we're going to solve quadratic equations using the null factor law, and here's our three scenarios. The first one here is x squared minus 2x is equal to 0. So first, let's just check that, make sure that yes, everything's on the left-hand side and it's equaling to 0. Tick. We're going to check to see if there's any common factor between these two terms, and there is. We can actually take out an x from this. Now, because there's already an equal sign that's there, your next line shouldn't have an equal sign starting off or having it leading. The common rule is you should always only have one equal sign per line. Because the equals is there, the next line just looks like this. So we take out x as our common factor, and what we're left with is x minus 2 is equal to 0. And just like the previous example, we're going to use a null factor law and state that either x is equal to 0 or x minus 2 is equal to 0. So at least one of these terms has to equal 0. So we're going to find out which terms are on. We've got the first one, x is equal to 0. You don't have to solve for this one. In this case here, we're going to plus 2 to both sides. And so we have x is equal to 0 plus 2, which is 2. So our solutions in this case is x is equal to 0 or x is equal to 2. So let's double check this. When you plug these numbers back into the original equation here, 2 squared is equal to 4, and minus 2 times 2, which is 4. 4 minus 4 is equal to 0. That works. And x equals to 0. 0 squared minus 0, because 2 times 0 is 0. 0 minus 0 is 0. So this solution works here. So we've got more than one solution. In this case, we've got 2. Second one here, and this is where we're going to implement a surd. Here we've got x squared minus 15 is equal to 0. There's no common factor of any sort, and there's nothing else. There's no. It's not in the format of ax squared plus bx plus c. So right now we have a subtraction here. So this is a difference of squares, no perfect square, but difference of squares. So right now this is going to be written as x plus square root of 15, x minus square root of 15, and this right here is equal to 0. And so in other words, what this is saying is that for your null factor law to be implemented, one of these terms has to be at least 0. So let's try the scenario where both of them are equal to 0. So x plus square root of 15 is equal to 0, or x minus the square root of 15 is equal to 0. And then all we have to do is just simply solve for x for both of these scenarios. So the opposite of plus root 15 is minus root 15, and this one here is plus root 15. So whatever I do to left hand side, I also do to the right hand side. Yep, lost my red, there we go. These two cancel, and so what we're left with is either x can be equal to negative square root 15, or x can be equal to positive square root 15. And these are our two plausible solutions. So when you plug these back in, the negative square root of 15 squared, because the negative will be included with the squared, this will result in a 15. 15 minus 15 is equal to 0, and again 15 minus 15 is equal to 0. These two are plausible solutions. Another way you can write this is x is equal to plus or minus the square root of 15. That is also a plausible solution as well, when you know that both of them numerically are the same and they just take on different signs. The last example here, 2x squared is equal to 50. I'm just going to write it on the bottom here. 2x squared is equal to 50. Right now I'm in a scenario where I know there's a common factor between every single term, and this is 2. So what I'm going to do is I'm going to divide both sides by 2, and you'll see why I'm going to do this. These two cancel out. Whatever I do to the left hand side, I do to the right. X squared is equal to 25. Pretty much these two equations mean exactly the same. It's just we're dealing with numbers now that are easier to handle. But unfortunately, right now it's not in the format of everything equaling to 0. So in order for this to happen, I'm going to balance this out. So I'm going to take away 25 on both sides, because I want to make this equal to 0. So right now I've got x squared minus 25 is equal to 0. So now it's in a format where I can factorize. This right here is the difference of perfect squares. So I'll draw it up in here. And it is perfect square because the square root of 25 is 5. So this can be written as x plus 5, x minus 5. By now, you should be used to getting from this step here straight to this step. Kind of like the previous one as well. Even if there's a surd involved, you should go from one straight to the other. You should recognize, yep, difference of perfect squares or difference of squares, because there's a squared number and there's a subtraction involved, or difference. So right now, here's a scenario using a null factor law. We can either say x plus 5 is equal to 0, or x minus 5 is equal to 0, and then we just solve for x for both sides. That's a plus 5 there. So we can have x is equal to negative 5, or x is equal to positive 5. Or we can write it as x is equal to plus or minus 5. So let's backtrack. This expression here, I'm saying backtrack a lot, I shouldn't. Let's take a few steps back. When we substitute 5 into here, 2 times 5 squared, which is 25. 2 times 25 is equal to 50. 50 equals 50. Positive works. And negative 5, obviously negative 5 squared gives me positive 25. 25 times 2 is 50. 50 equals 50. These two solutions suffice. Alright, now let's get into situations where we have an actual ax squared plus bx plus c format. So we're going to solve for the following quadratic formulas. First one here, we have x squared minus 5x plus 6 is equal to 0. And we need to solve for what our x value can be. So what I'm going to do is, because the leading term x squared only has a coefficient of 1, I'm going to try to look for two numbers that when multiplied will give me a positive 6, and then when added will give me negative 5. I know these x values are minus 3 and minus 2. So x minus 3 and x minus 2 is equal to 0. And all I've done was change this format into the factorized format here. Because remember, when you expand this out again, you'll end up back to x squared minus 5x plus 6. Using Null Factor Law, either x minus 3 is equal to 0, or x minus 2 is equal to 0, meaning either x is equal to 3, or x is equal to 2, and there are our two plausible solutions. So all that hard work of learning how to factorize leads us down to being able to solve for our x value. Double check, 3 squared is equal to 9 minus 15. So 9 minus 15 will give me negative 6. Negative 6 plus 6 gives me 0. Boom, that works. And 2 squared, so 4 minus 5 times 2, which is 10. So 4 minus 10 gives me negative 6, plus 6 gives me 0. Boom, that works as well. These are the only two plausible solutions for this specific quadratic equation. B, we have x squared plus 2x plus 1 is equal to 0. Again, it's in that format of everything equaling to 0. We're going to look for two numbers that when multiplied together gives me 1, and then when added together gives me 2. This is a pretty simple one. I was going to say silly one, I don't know why it's silly. X plus 1, x plus 1, or x plus 1 squared. Now here is a scenario where there's only one plausible solution, because either x plus 1 can equal 0, or x plus 1 can equal to 0. So our solution in this case is x is equal to negative 1. This is the only solution that works. When you substitute x equals negative 1 into here, negative 1 squared is 1 plus 2 times negative 1, which is negative 2. So 1 minus 2, which gives me negative 1, plus that 1 again gives me 0. It's the only solution that works. Now, alternatively, you could get into the format where it looks like this: x plus 1 squared is equal to 0. Then the inverse operation of squaring a number is square rooting a number. So this will lead me to x plus 1, and the square root of 0 is just 0. So this is where we get x is equal to negative 1, which is still the same solution. It just goes to show that technically you are getting two solutions. It just so happens that those two solutions are the same. And so we have this x is equal to negative 1. And if you want to delve into what that looks like when sketching, it just means that when y is equal to 0, x will equal negative 1. And this is the only point where it touches on the x-axis, and x is equal to negative 1. Again, you'll delve into that later down the track. All right, last example before we get into the second part. Here we have a scenario where our a value is 10. So it's not a simple factorization as follows. You have to write what your a value is. So a is equal to 10, b is equal to negative 13, and c is equal to negative 3. A times c is 10 times negative 3, which is negative 30. So we're looking for two numbers that when multiplied will give you negative 30, and then when added will give you negative 13. In this case here, this would be negative 15 and positive 2, if I'm not mistaken. Negative 30, 15, yep, negative 15 plus 2. So that means we're going to change this 10x squared minus 13x minus 15x plus 2x minus 3. And we've purposely done this so we can shift this around. Thought this was looking a little bit wrong, you silly goose. You're changing this negative 13x to be minus 15x plus 2, and this is where you do the grouping. I'm like, oh, there's one extra term that's in there. That silly me. Okay, so this is what we're grouping. We're grouping that, and we're grouping that, and we're looking for any common factors that we can take out. Within the first one, we have 10, so 5x, and then this turns into what's left over is a 2x minus 3 plus 1. 2x minus 3. I noticed that 2x minus 3 was within there, so I've purposely taken out 1 as a common factor. So 2x minus 3 is our common factor, so 2x minus 3. And what we're left with is 5x plus 1. This is equal to 0. So we've manipulated this and we've changed this around. So it looks like this. Using a null factor law, we have 2x minus 3 is either equal to 0 or 5 or 5x plus 1 is equal to 0, and then we just solve for x's for both sides. Focus on the first one first. So 2x is equal to 3, meaning x is equal to 3 over 2. You would just leave it in that format. 3 over 2, 1.5, but 3 over 2 you'll leave it as. Or, in this case here, minus 1, 5x is equal to minus 1, meaning x is equal to negative 1 over 5. You will get into a scenario where you will get fraction answers, and sometimes you might even get negative fraction answers, which I have in this case. When you double check it, if you get a complicated version of this where you want to double check it, you can just simply use your calculator to double check it if you don't want to deal with pesky fractions, especially negative fractions and squaring negative fractions. But suffice to say that these two solutions will work when you do substitute it in. It will equate to 0. Alright, that's the first part. I'll see you guys in the second part.